Sometimes when you use a pure component optimization, you'll run into unexpected problems. And this happens particularly when your state has mutable structures like objects and arrays, and if you're actually mutating these structures. So let me demonstrate this problem with an example. Let's go to the State API class where we manage the store, and we are managing the list of articles here as an object, which is a mutable data structure. So I'm going to do an example of mutating this structure. So let's assume that after 1 second, we receive another article from the API. So to simulate that, after 1 second, so I'll do a set timeout operation that gets invoked after 1 second. And in here, we're going to have a fake article, and we'll append this fake article to the articles object that we have on the state. So I'll copy this fake article from the raw data. So we'll copy raw data.articles first, and we'll just give it a fake ID. So now I have my data articles as an object, and if we want to add this fake article, one option would be to just do this .data.articles for this fake article ID equal the fake article. And I also need to notify subscribers, right? So this .notify subscribers call in here. And what we're doing here is we're basically mutating the state. And if we're mutating the state, the pure component optimization that we did in the app component is actually going to give us a problem. Because as the pure component sees it, the article's object reference did not really change. So if we test what we just did, it's not going to work. I will not see this new article. Again, because we are using a pure component. In fact, if we remove the pure component optimization from both the app component and the article list component, then what we just did should work. Let's test. So render the first list, and after 1 second, the fake article should show up in the list. So the fact that we mutated our state is now preventing us from using pure components, which is bad. So I'm going to put back the pure components and go back to the same problem. Now we are changing the state of this component, but we are not re-rendering because we are using a pure component optimization. So how can we do the exact same operation without mutating the state? We can use a copy operation. So something like this.data equal, start by copying the current data, then change the articles object, and start by copying the current articles object from the data, and then add the new article. So in here, that would be fakearticle.id is the fake article. So what we're doing here is practically equivalent to the commented outline, but without mutating the state. We are copying the current state and then modifying a copy of the current state, which means for the pure component, the previous object and the new object are going to be different, and things should work even though we have pure components. Let's test. Re-render, we get the list of articles at first, and then after 1 second, a new article shows up. And again, we're still using pure components here and here. However, now we are not mutating our data structures. So here's the advice. Always use immutable data structures. Never mutate your data structures directly, because that's going to have performance implications on your applications eventually. However, when you start copying objects to avoid mutability, things might start to be harder than they should. Right here, we needed a few lines of code to replace a single line of code. And we have to do these manual copy operations, which actually cost something in terms of the resources available in the browser. So although we removed some complexities by not mutating the data directly, we added new complexities of needing to copy data around and use memory and CPU to do so. So the best of both worlds is to use some kind of immutability helper. Now you have options here, and the first option is the immutability helper package, which is a very simple helper that allows us to update an object without mutating it. So it actually returns a new copy of the object. And it uses syntax similar to MongoDB here, $set, $push. So this is actually the minimum you should use in a React application if you're managing your own state and you want to utilize the pure component optimization. If you want a more advanced option, you can use the Immutable.JS library, which has a lot more features. Like, for example, you can work with lists and maps. And not only you can update these data structures in an immutable way, but you can also do operations like merge and deep merge and deep update. So it's a very rich library to work with immutable data structures. And the cool thing about it is that it actually uses shared data to do these immutable operations in a very optimal way without wasting resources unnecessarily. But it does add some complexities to the project. However, I think the complexities that it removes are much bigger than the complexities that it adds. So I've actually started using Immutable.js in all of my React projects because I think the value it adds is simply great.